Hello everyone, Mr. Hissner here, and today we're going to continue down the path of similar triangles. Now, we're going to look at similar triangles like we saw yesterday, um, and we're going to do so in a little bit more of a complex light. So, um, let's look. Again, it looks like these triangles have a little bit of algebra going on, so we're not going to be able to use our scale factor the way that we do when we have all numbers, but instead, we're still going to have to use a proportion. We're still going to have to give this a solve. So now we are rolling. And when you have deep pockets, you can't find your phone in them. So let's look at some corresponding sides. Now, clearly, it looks like to me that BC and DE are corresponding. And so what I'm going to do here is I'm going to make a proportion. Oops. Okay, and now really I have to look at this other one. Now we have two triangles here. We have this big triangle here in green, and then we have this small triangle here in yellow. Okay, so that's how I'm going to kind of look at these. So let's look at AB, because it looks like AB and AD are corresponding. Well, AB is this whole thing. It looks like AB is actually AD plus DB, which is 28. And AD, this one, is just this piece, which is 20. Now, notice that 28 and 2x plus 3 are both part of the big triangle. Okay? And then we have 15 no, my bad. 20, yes, 20 and 15, and these are both part of the small triangle. All right, so not only am I matching up corresponding sides up and down, but I'm also matching triangles. So that's how you want to think of these. You want to set up your proportion correctly. So let's do some solve. Well, this is actually 7 over 5. We saw this one before. 7 over 5. So I'm going to use the smaller numbers because I can math. And okay, can I really though math? Let's see. 15 times 7, 15 times 6, 15 times 7 is 75. No. Yes. 75. 2x times 5 is 10x. 5 times 15. 5 times 3 is 15. And yeah, so, oh, perfect. This is going to be a great and easy problem to solve. I'm going to subtract 15 from both sides, do a little box here, and just continue working on the easiest problem that actually was ever made. And we find x is equal to 6. So, what's the difficult part? Well, of course, a horse is a horse, of course. What the difficult part is setting up your proportion. And really what the difficult problem with this is knowing that you have corresponding sides and being able to recognize what sides are corresponding and remembering segment addition. Man, you remember that stuff, segment addition? I thought that went away. Surprise, it didn't. And why would it? It's geometry. So I know I'm asking you a lot here. I'm asking you to remember what you're taught in school and in class. And for some of us, that's a big ask. But for some of us, it's just what we do normally. So, yeah, corresponding parts, setting up ratios, matching up your triangles and your scale factor appropriately. And yeah, really there's nothing to this, all things considered. I know some of you might be looking at this and freaking out, but yeah, set up your proportion and give it a solve. I mean, literally, it's a super easy problem. I mean, we all can agree that this problem is easy. Once we're here, we're home free. This problem, a little bit more intimidating, I will admit. However, I mean, overall, it's a squeezed lemon. Thanks for watching, guys.